Yes, I think we all agree that there is not one single solution to antibiotic reduction. But what I will talk about today is how bacteria in animal feed can be controlled. And here we think the key is lignosulfonic acid. In livestock feed, organic acids have gained worldwide acceptance as the preferred solution to replace antibiotic growth promoters. And in Scandinavia, organic acids have been used since the 80s. But as many of you know, the use comes with some challenges. I would like to introduce you to Borregaard's patented technology that consists of lignosulfonic acid in combination with organic acids. This technology offers some unique and documented benefits when it comes to bacterial control, safety and handling, and not least sustainability. So let's have a closer look at these benefits. But first, who is Borregaard and what is lignosulfonic acid? Borregaard is a global company with head office in Norway that operates the world's most advanced biorefinery. We produce sustainable bio-based products from wood, including specialty cellulose, vanillin, and lignin-based biopolymers. These products are sold into a wide range of applications worldwide, which includes animal feed industry. One biopolymer that is especially developed for animal feed is lignosulfonic acid. This is a large molecule with a low pH. When combining this lignosulfonic acid with one or more organic acids, we get products with unique benefits, and this product range is sold under the SoftAcid brand. It is the presence of the lignosulfonic acid that gives the product its name Soft. And this is due to the properties that lignosulfonic acid have, that an ability to moderate the aggressive nature of the organic acids, but without reducing efficiency. And regarding efficiency, let's have a closer look at a laboratory study that was done with Salmonella. And this study was done at an external lab in Spain, where the effect of 3 different additives were tested. The products tested were SoftAcid 5, which consists of lignosulfonic acid and formic acid, buffered acid, which consists of formic acid and ammonium formate, and the last one is ammonium formate. The graph shows minimum inhibitory concentration for SoftAcid in green. And as we can see, a concentration of 5 ppm is enough to control the Salmonella. So by far the most effective of the tested products. And here the explanation is pH. SoftAcid has a lower pH compared to the other products tested. And one thing is the instant effect, but how about the long-term effect? We decided to do a follow-up study at the same lab in Spain, where Salmonella recolonization were studied. The graph shows numbers of colony-forming units per milliliter over a period of 30 days. And it was interesting to note how well the treatment with SoftAcid, that's the green line, performed over time. As you can see, the other treatments experienced Salmonella recolonization already after 7-8 days. So why is SoftAcid more effective over time compared to the other products tested? The theory we have is that in an acidic environment, lignosulfonic acid will attach to the protein part of the bacteria and block their communication, which then prevents colonization. This kind of bacterial communication is called quorum sensing. And in addition, there is less evaporation of formic acid from SoftAcid compared to the other acidifiers, which also contribute to a long-lasting effect. Let's actually have a look at evaporation from some of these acidifiers. Evaporation of organic acids in feed production is a significant problem. And measurements done during a feed pellet production have shown that as much as 20% of the formic acid added to the formulation can be lost via evaporation. And this results in reduced antibacterial effect in the feed, since then less acid is left, and also increased health risks for the worker in the feed mill due to acid vapor in the production area. The level of formic acid in the air during feed production was measured, and the concentration was measured to 0.7 ppm. When the feed production was changed to SoftAcid, the evaporation of acid was significantly reduced. 0.2 ppm was measured in the air with SoftAcid compared to 0.7 with formic acid. This results in good bacterial antibacterial effect and also much safer and more pleasant working environment. Another important aspect when it comes to safety and handling is corrosion. Corrosion on equipment is linked to high maintenance cost and is therefore of great importance. On this slide, you can see 3 nuts of carbon steel and how they look after 72 hours in formic acid, in soft acid, and in water. It is clear that a nut exposed to formic acid is corroded, while the 2 other nuts seem to be unaffected. And experiments done at Sintef Material Technology in Norway show that the corrosion rate of soft acid on carbon steel was reduced by more than 95% compared to pure formic acid. And a reduction on concrete showed that we see a reduction of 75%. Most of our soft acid products are also classified as non-corrosive to skin. And it is the presence of the lignosulfonic acid that helps moderate the aggressive nature of the organic acids by forming a protective layer on the solid surfaces. So, in addition to a very good effect on bacterial control, soft acid products offer a significant advantage when it comes to safety and handling. I would also like to spend a minute on sustainability before I summarize my presentation. And Norsus, one of Europe's leading research institutes on life cycle assessments, have conducted an LCA comparison for soft acid and formic acid. This study showed that by replacing formic acid with soft acid, you reduce your CO2 emissions by 38%. The reduction comes from the lignosulfonic acid, which is a part of soft acid that has a favorable CO2 footprint compared to the formic acid. And 38%, yeah, that's a significant number, but how much is that really? And as an example, I will use Norway and the annual pig feed production there, which is around 500,000 tons. If the formic acid used in this feed is replaced with soft acid, the emissions are reduced equivalent to the annual emissions of 800 cars. To summarize, I would like to repeat the benefits offered, but first I would like to again emphasize that the key in soft acid technology is the lignosulfonic acid. It is a unique solution for antibiotic reduction in animal feed. And the benefits you can achieve with this technology are an effective bacterial control and excellent performance over time, and safer and easier handling as a result of reduced evaporation and less corrosion. And last but not least, a very favorable CO2 footprint. SoftAcid is a cost-effective alternative to all feed-related applications where organic acids like formic, acetic, and propionic acids are used. And if you are interested in more information about lignosulfonic acid or SoftAcid products, please visit our website or contact us by email.